We have seen electroplating, types of electroplating, factors governing electroplating. Let us discuss taking example of chromium, how electroplating is done. So chromium plating is done by electrolyte consumption method. So there are two types of chromium plating, that is hard and decorative chromium plating. The This chromium plating, as we have discussed earlier, it's a passive metal. Chromium is a passive metal. So for all passive metals, electrolyte consumption method is done. So what is electrolyte consumption method? So here anode is inert and the coating material is the cathode. Okay, so we're going to do it by electrolyte consumption method. So anode is inert. It might be lead, tin alloy, and cathode is the base metal which takes coating. You're going to put it on an electrolyte of sulfuric acid or chromic acid mixture and pass a power DC power supply. So now let us see what are the various bath composition, current, and pH required for decorative and hard chromium. So anodes used in decorative and hard chromium plating both are insoluble anodes like lead and tin coated with lead oxide. So cathode, irrespective of the chromium platings, it might be decorative or chromium hard, for both are going to use the substrate, that is the base metal which takes the coating. So for bath composition, so it is 100 is to 1 ratio chromic acid and sulfuric acid. If you are adding 100 ml of chromic acid, you are going to add 1 ml of sulfuric acid. If you are adding 1000 ml of chromic acid, you are going to add 100 ml of sulfuric acid. It is 100 is to 1 ratio of chromic acid and sulfuric acid. Current density is 100 to 200 for decorative chromium, and for a hard chromium it is 215 to 430. Current efficiency is 8 to 12 for decorative chromium. For hard chromium it is 10 to 15%. So pH it is 2 to 4. It is common because the bath composition is 100 is to 1, right? Chromic acid and sulfuric acid. So therefore the pH will be common. It is acidic. So temperature it is 45 to 55 degrees Celsius for hard decorative, and hard chromium plating it is 43 to 66 degrees Celsius. So at anode, when you pass the current, what will happen? So anodic reaction, that is chromic acid, it contains chromium 6 plus, so it undergoes oxidation to give Cr3 plus. So at cathode, these Cr3 plus will move towards the base metal, undergoes reduction to give you Cr. This Cr will get deposited on the surface of the base metal. Okay, so the applications it is used, so the decorative chromium, it is used in all surgical instruments or optical instruments. So your optical glasses, it might be made up of what? Chromium plated. Your surgical instruments, maybe scissors, maybe your forceps, everything it will be made up of, it will be coated with chromium. So decorative finish for automobiles, your mirrors, your dashboards, everything, mud guard, it will be chromium plated. Drilling machines, that hard chromium is given for drilling machines, bore wells, so that is given for hard chromium plating is done. A small video which shows the chromium plating, your bullet, so bullet handles, so bullet, the petrol tank, the mirror, everything is done, is given chromium plating. I'll just show you.
Everyone appreciates the shine of chrome, but chromium ore is not only abundant and therefore expensive. Also, pure chromium is a brittle metal that is hard to work with. How then can just about anyone afford beautiful chrome accessories?
Chromium plated.
This is accomplished by the deposition of chromium ions onto a base metal using electrolysis in a process called chromium electroplating. The preparation of the base metal is essential for quality plating. The base metal must first be cleaned to remove both grease and oxidation. Often the metal is then chemically etched to improve adhesion of chromium ions. In the electrolysis unit, the base metal is used as the cathode, and a lead bar immersed into chromium solution is used as the anode. As direct current flows, chromium metal is deposited onto the base metal. When the desired depth of plating has been reached, only a final rinse and polish is needed. Even a thin layer of chromium provides the beautiful, lustrous finish. Objects subjected to greater wear need thicker layers of chromium. As an added benefit, the chromium provides a protective layer for the base metal beneath.
So now let us see why these chromium anodes are not used. Why it is done only by electrolyte consumption method. Why it is an electrolyte consumption method? Because chromium, if you use anode, it strongly passivates in acid media. Because it is as soon as you dip in acid, it will form chromium oxide. This chromium oxide will form a layer on the surface of the anode, and it prevents chromium from further undergoing oxidation. This is one of the reason. Other reason is the anodic efficiency is 100%, whereas cathodic efficiency is 10 to 20%. That is for every minute. So 100 chromium Cr3 plus is formed, but at the same time only 10 to 20 Cr3 plus is converted to Cr. So other reason is as because of this 10 to 20% of chromium 10% of cathodic efficiency, the Cr3 plus concentration will gradually increase in the electrolyte path solution. So because of this, what happens? We'll get a black deposits. So because of all these three reasons, we're not going to use anodic consumption method. Instead, we follow electrolyte consumption method. The main three reasons: chromium anodes passivate strongly in acid media. Adic efficiency is 100%, whereas cathodic efficiency is 10 to 20%. Other important reason is the chromium 3 plus concentration increases, which gives black deposits. So these are the three reasons because of which we are not going to use chromium electrolyte consumption method. Thank you.